Compatible system of first order equations. We consider first order partial differential equations. And these are fxyz, pq is equal to 0. We denote it by 1, and second equation is gxyz, pq is equal to 0. Now these two equations 1 and 2 are compatible or non-compatible as when every solution of one is also a solution of the other, means same solutions we have. And now we want to find the condition for which 1 and 2 are compatible. So 1 and 2 can be solved to obtain explicit solution हमें obtain हो जाएगा इसका. So to obtain the explicit expressions for P and Q given by P is equal to phi xyz and Q is equal to psi xyz. So let's say this is equation 3. Now the condition that equations 1 and 2 should be compatible then reduces to the condition that the system of equation 4 should be completely system of equations of 3. Condition is this: equations of 3 should be completely integrable. That is, we can write that the equation dz is equal to p dx plus q dy, or we put values of p and q, phi and psi, phi dx plus psi dy. So let's say this equation 4, this is integrable. This equation should be integrable. And this equation is integrable. We know that p dx plus q dy plus r dz is equal to 0 is integrable p del q upon del z minus del r upon del y plus q del r upon del x minus del p upon del z plus r del p upon del y minus del q upon del x is equal to 0. This is the condition. So we apply this condition on 4 to be integrable. So this will be equation 4 will be integrable. Here the PQR are phi, psi and minus 1. So we write equation 4 is integrable if pi del psi upon del z minus 0 plus psi 0 minus del phi upon del z minus 1, that is plus minus 1, into del phi upon del y minus del psi upon del x is equal to 0. So if we simplify it, it becomes del psi upon del x from here, then plus phi del psi upon del z, del phi upon del y minus psi del phi upon del z. This becomes plus because we have brought on this side, so this becomes plus. Now substituting from equations 3 in 1, and differentiating with respect to x and z respectively, we get del f upon del x plus del f upon del p, because it is p is equal to phi xyz, and in equation 1 is f xyz pq. So del f upon del x plus del f upon del p, del phi upon del x, because phi is function of x, plus del f upon del q, and del psi, because another is psi xyz. So del f upon del q and del psi upon del x is equal to 0. This is with respect to x. Now with respect to z, del f upon del z plus del f upon and del p upon del z plus del f upon del q and del psi upon del z is equal to 0. So let's say this is equation 5 and equation 6 and 7. Now from 6 and 7 we can write we multiply second equation by 5 and then add them. So del f upon del x plus phi del f upon del z plus del f upon del p we take common in these two terms, and we get del phi upon del x, and second is multiplied by phi. This is phi del phi upon del z plus, now from these two we take del f upon del q common, del f upon del q, and it gives del psi upon del x plus phi del psi upon del z is equal to 0. And similarly we can write or G, because another equation is gxyzpq. Here also we put the values of p and q in the form of phi and psi, and then get this type of equation as we got here, which is 8. So we can write del g upon del x plus phi del g upon del z plus del g upon del p del phi upon del x plus phi del phi upon del z plus del g upon del q del psi upon del x plus phi del psi upon del z is equal to 0. This is equation 9. Now from equation 8 and 9 we can write and suppose we take Jacobian, J is equal to Jacobian of f and g. So this is equal to del f g upon pq is equal to not 0. So we use this, and by equation 8 and 9 we can write del psi upon del x plus phi del psi upon del z, the last term, is equal to 1 upon j del f g upon del y q plus psi del f g upon del z q. With minus sign. We see how to get this. So from here we have this term which is here, which we have written here left hand side, is equal to all these terms on another side divided by this term. So let's see equation 9 by del f upon del p and subtract. So what happens? This becomes del f upon del x del g upon del p. We club the terms also. So the first term of second equation, that 9th, minus del g upon del x del f upon del p. Then we have plus phi common and del f upon del z into del g upon del p minus del g upon del z into del f upon del p. Then we have del phi upon del x we can take common, and del f upon del p into del g upon del p minus del g upon del p into del f upon del p. So this cancels out. Plus phi and del phi upon del z. This comes del f upon del x into del g upon del f minus del g upon del p into del f upon del p. Then we have the last term, and it has common as del psi upon del x plus phi del psi upon del z del f upon del q into del g upon del p minus del f upon del p into del g upon del q is equal to 0. So one correction, these are p. These are p, see the term, these are del f upon del p and del g upon del p. So this also cancels out, and now only the terms, this is basically del of fg upon del of xp plus phi, this is del of fg upon del of zp, and if we take this on another side, it becomes, the order of this will change, so del of fg, the sign will become plus this and this will be minus upon del pq, and we know this Jacobian, we know del of fg so this is what we had here. So what we did, we took this term here, and this is j of fg is, so this has come in denominator and this term is here. So this is what we had seen. If we go back, here we see the same term, del psi upon del x plus phi del psi upon del z is equal to 1 upon j del of fg upon del of xp plus phi del of fg del zp. Similarly, for second equation, when we are differentiating with respect to y and z, it was for x and z. If we are differentiating with respect to y and z, we can find out the, so again substituting, from equation 3 in 1 and differentiating with respect to y and z, write directly that del phi upon del y plus psi del phi upon del z is equal to 1 upon j, here it will be minus 1 upon j del fg upon del yq and plus psi del fg upon del zq. Now suppose this equation is 10 and this is 11. So substituting from equation 10 and 11 in 1 and replacing phi and psi by P and Q respectively, then we obtain equation 5 से अभी हमने देखा था that del psi upon del x plus phi del psi upon del z is equal to del phi upon del y plus psi del phi upon del z, और यही टर्म्स अभी हमारी ऑब्टेन हुई हैं लेफ्ट हैंड साइड अगर हम चेक करें, del psi upon del x plus phi del psi upon del z, and from second equation this term is there del phi upon del y plus psi del psi upon del z. तो हम जो जैकोबियन की टर्म है which we have got in right hand side, these two are equal. So from first this is the case is equal to minus 1 upon j. These are from equation 10 and 11. Del fg upon del yq plus q del fg upon del zq. एंड अगर हम इसे ऐड कर लें वी ब्रिंग बोथ, देन दिस बिकम्स 0. इट मीन्स और एफ जी इज इक्वल टू 0. एंड व्हाट इज एफ जी? वेयर एफ जी इज del of fg upon del of xp plus p del of fg upon del of zp. These terms, then we have taken j common suppose, and this is with plus del of fg upon del of yq plus q del of fg upon del of zq. So this is equal to fg and this is equal to 0. अब एक पर्टिकुलर केस करते हैं इसी आर्टिकल का और ये दिखाते हैं कि फर्स्ट ऑर्डर पार्शियल डिफरेंशियल इक्वेशंस जो कि p is equal to pxy and q is equal to qxy are compatible if and only if condition है del p upon del y is equal to del q upon del x. तो इसे प्रूव करते हैं, then we will do some examples based on it. This is a particular case where we want to show that first order PDE, which can be written as P is equal to capital PXY and Q is equal to capital QXY, are compatible if and only if del p upon del y is equal to del q upon del x. So we prove it. dz is equal to del z upon del x dx plus del z upon del y dy, which is equal to p dx plus q dy. We know that p is del z upon del x and q is equal to del z upon del y. So we mark it 1 and this is 2. That is why we have written this p dx plus q dy. And we have assumed p is equal to capital PXY and q is capital QXY. So these equations given by 1, the given PDE by 1 are compatible that is P and Q. If and only if the single differential equation dz is equal to capital P dx plus capital Q dy is integrable. And capital P and capital Q, these are functions of xy. Functions of xy. Hence P dx plus Q dy, ये क्या हुई? एग्जैक्ट डिफरेंशियल इक्वेशन. किस केस में? इफ एंड ओनली इफ del P upon del Y is equal to del Q upon del X. अगर ये कंडीशन सेटिस्फाई हो रही है तो P dx plus Q dy जो है एग्जैक्ट डिफरेंशियल इक्वेशन है. एंड therefore this equation 3 is integrable if and only if del P over del Y is equal to del Q over del X. So ये कंडीशन हो गई. Now if this is the condition, del P over del Y is equal to del Q over del X, then the system of given partial differential equations जो कि P and Q है is compatible. Hence these equations will P, which is del Z upon del X, and Q, which is del Z upon del Y, they will have common solution, or they will have same solution. And second, this is first point, and second point is if they are not compatible, then these equation have no solution. अब कुछ examples देखते हैं. So first example is show that the differential equations 5x minus 7y, this is equal to del z upon del x, and del z upon del y is equal to 6x plus 8y. These two equations are not compatible. And this question has many parts, so we write all. Second is del z upon del x is equal to 5x minus 7y, and del z upon del y is equal to the same equation is equal to 6x plus 8y. Possess common solution. We have to check. कॉमन तो तब होगा जब कॉम्पेटिबल हो. नो सॉल्यूशन. अगर ये नॉट कॉम्पेटिबल है तो नो कॉमन सॉल्यूशन. And no solution, none of these. So no solution will be the answer for this if first is true. No solution and none of these. So mark करना है point, mark the point. Then third part is let's mark it A, B, C. So these will be different. C is show that the differential equation P is equal to x square minus ay, q is equal to y square minus ax are compatible, and find their common solution. Then next is D. Here differential equation is del z upon del x is x plus y square, and del z upon del y is x square plus 2xy minus y square are compatible, and solve them. Then next is E. Show that P is equal to x minus y upon x square plus y square, and Q is equal to y plus x upon x square plus y square are compatible, and find their solution. Let's take one more. P is equal to 1 plus e to the power x upon y, and Q is equal to this. Here also we have to find out whether they are compatible, and their solution is to be found. So as we know that P is equal to del z upon del x, and Q is equal to del z upon del y. So we have seen they are not compatible, and the answer for B is no solution. For C we differentiate it, we get minus a and minus a, del P over del y and del Q over del x. So they are compatible because they are equal. Now for solution we find dz, which is P dx plus Q dy. So dz is equal to this. Now we write it, dz is equal to x square dx plus y square dy, minus a we take common, and y dx plus x dy. This gives x cube on integration, z is equal to x cube plus y cube upon 3, and minus this is d of xy, so this is xy, plus some constant, say c is r. So this is the answer. Next D part is we have to find out del z upon del x is x plus y square, and del z upon del y is x square plus 2xy minus y square, which is x minus y whole square. So del z upon del x is given in the question, x plus y whole square, and del z upon del y is x square plus 2xy minus y square. Now we find out del P upon del y, because this is equal to P also, and this is equal to Q also. So we check whether these two, del Q over del x, these two are equal or not. So del P over del y is 2x plus 2y, and del Q over del x is 2x plus 2y. So they are equal, it means compatible. And once compatible, we have to find its solution. Solution means dz is equal to p dx plus q dy. We put values of p and q in this. So dz is equal to x plus y whole square dx plus x square plus 2xy minus y square dy. So we integrate this equation dz is equal to, and we note that right hand side of this equation must be an exact equation, exact differential equation. So by method of solving an exact differential equation, on this I will make one video, as I already said. The topics related to exact and other related methods with the partial, which are not being covered in this series, which is related to IS completely, but in between, wherever we need these tidbits, we will be doing that. By method of solving an exact differential equation, it is z is equal to integral x square plus 2xy plus y square dx. Here we treating y as a constant, and plus integral x square plus 2xy minus y square dy. And here what we integrating terms free from x, integrating terms which are free from x, plus const. So this becomes z is equal to y as a constant means x cube by 3 plus 2x square by 2 means x square y, plus y as constant means y square x, then we come to second term. So free is only y cube means y square, which is minus y cube upon 3 plus c. Only this term is free. So this is the answer. Next is p is equal to x minus y upon x square plus y square. And q is equal to y plus x upon x square plus y square. So we have to show that these are compatible or not, and if so, we have to find out the solution. So del p over del y is, because this is equal to capital P also, so this term is 0, then denominator whole square, then x square plus y square into differentiation of this minus numerator and differentiation of this denominator, which is 2y. And it comes minus x square minus y square minus 2y square. It becomes plus. So plus minus means y square minus x square upon x square plus y square whole square. Then we do del q over del x is equal to y का 0 हो गया plus x square plus y square whole square, then this is x square plus y square into 1 minus x into 2x. So this comes y square minus x square upon x square plus y square whole square. So these two are equal. it means compatible, and once compatible we need to find out its solution. So solution is, here also we will see whether dz is equal to p dx plus q dy, this is an exact or not. So dz is equal to x minus y upon x square plus y square dx plus y plus x upon x square plus y square into dy, integrating and noting that right hand side of this must be an exact differential equation, तो वही मेथड यूज करेंगे. So integrating z is equal to integrating x minus y upon x square plus y square dx. Here what we do, y as constant we will take, and plus this is dx integral y plus x upon x square plus y square dy, and here terms which are free of x plus constant x square upon 2. So we know that dx upon x square plus a square is equal to 1 upon a tan inverse x upon a. So the same formula if we apply, y is constant, so minus y upon y tan inverse x upon y. Next term plus y square by 2, and then we don't have any free term, plus c. So we further write x square plus y square by 2 minus tan inverse x upon y plus c. This is the answer. Next is p is equal to 1 plus e to the power x upon y, and q is equal to e to the power x upon y 1 minus x upon. So del p over del y is equal to e to the 0 plus e to the power x upon y, and then differentiation of x upon y. So x is constant minus x upon y square, because 1 upon y का होगा minus 1 upon y square, and del q over del x is, now it has two parts. So first we do e to the power x upon y, और इसे x के रिस्पेक्ट में करना है. So this comes 1 upon y into 1 minus x upon y plus e to the power x upon y into minus 1 upon y. So इसे सिंप्लीफाई अगर करें तो e to the power x upon y कॉमन लिया, 1 minus x upon y minus 1 upon y, and here y is also there, so this is 1 upon y x upon y square minus 1, so this cancels out. So this is e to the power x upon y into minus x upon y square, ये इंटीग्रल आ गया. और यहाँ से देखें तो ये भी था minus x upon y square e to the power x. So these two are equal, so compatible है. अब इसका solution find out करना है. तो solution dz is equal to p dx plus q dy. So this will be equal to 1 plus e to the power x upon y dx plus e to the power x upon y 1 minus x upon y dy। इंटीग्रेट करेंगे तो z इज इक्वल टू, और ये एग्जैक्ट होना चाहिए तो उसी हिसाब से इंटीग्रेट करेंगे कि इंटीग्रल ऑफ दिस, जबकि y कांस्टेंट है और जबकि फ्री फ्रॉम x टर्म्स हैं, टर्म्स फ्री फ्रॉम x, तो ये z इज इक्वल टू होगा एंड e टू द पावर x अपॉन y प्लस e टू द पावर x एंड देन x अपॉन y का करेंगे तो दैट विल बी 1 अपॉन y। एंड इस केस में कोई भी टर्म फ्री फ्रॉम x नहीं है, प्लस c, सो यही आंसर होगा। z इज इक्वल टू x प्लस e टू द पावर x अपॉन y इंटू 1 अपॉन y, और सेकेंड टर्म में कोई भी फ्री फ्रॉम x नहीं है तो प्लस 0, तो ये आंसर है इसका। इस एग्जाम्पल में we have to show that the equations xp minus yq is equal to x and x square p plus q is equal to xz are compatible and find their solution। सो यहाँ पर हम मानते हैं एफ एक्स वाई जेड पी क्यू, जैसे आर्टिकल किया था ये क्वेश्चन उसी तरह से होगा, इज इक्वल टू एक्स पी माइनस वाई क्यू माइनस एक्स इज इक्वल टू 0, एंड सेकेंड जो है वो है जी एक्स वाई जेड एंड पी क्यू, दिस इज एक्स स्क्वायर पी प्लस क्यू माइनस एक्स जेड इज इक्वल टू 0। सो ये 1 हो गया और ये 2 हो गया। अब हम फाइंड आउट करते हैं जैकोबियन। सो डेल एफ जी अपॉन डेल एक्स पी, so the first equation we have taken as fxyz pq and second given equation as gxyz pq, और जब से हम आर्टिकल जैसे किया था उसी लाइन पर करेंगे। डेल एफ अपॉन डेल एफ जी अपॉन डेल एक्स पी इज इक्वल टू दिस डिटर्मिनेंट, पहले एफ को एक्स के रिस्पेक्ट में, फिर पी के रिस्पेक्ट में, जी को एक्स के रिस्पेक्ट में, जी को पी के रिस्पेक्ट में। तो यहाँ से वैल्यूज कैलकुलेट की। सो डेल एफ अपॉन डेल एक्स इज पी minus 1 and del f upon del p is only from here, that is x, then del g upon del x is 2xp minus z, and then del g upon del p is x square। so if we simplify it, it comes p minus 1 x square minus x 2xp minus z is equal to 0। so if we open it, it comes px square minus x square minus 2x square p and plus xz is equal to 0। so minus x square p minus x square plus xz, so this is del f g upon del xp। सिंप्लीफाई करके हमें ये ऑब्टेन हुआ। सिमिलरली वी कैलकुलेट del एफ जी अपॉन del जेड पी, del एफ जी अपॉन del वाई क्यू del fg अपॉन del zq, ये वैल्यूज कैलकुलेट करनी है. So this will be del f upon del z, del f upon del p, del f upon del g upon del z, del g upon del p, del f upon del y, del f upon del q, del g upon del y, del g upon del q, del f upon del z, del f upon del q, del g upon del z, del g upon del q. ये वैल्यूज कैलकुलेट कर ली जाए. So this comes 0 x minus x x square. So this is 0 plus x square, which is equal to x square. If we calculate this, this comes minus q minus y 0 and 1. So this comes minus q, and this is 0 minus y minus x 1. So this is xy with minus sign. So now we calculate fg. Fg was del f g upon del xp plus p del fg upon del zp plus del fg upon del xq plus q del fg upon del zq. This is equal to p minus 1 x square minus x 2x p minus z minus px square minus q minus xyq as it is. We have kept, so need not to do this one. Now we simplify this. So this is equal to px square minus x square minus 2xp x square p plus xz minus px square minus q minus xyq. And if we see x square p plus q minus xz, so these are opposite sign, so this is equal to 0. These three terms are 0 from equation 2. So remaining is, and from here this is x square p minus, and this, so minus x, this term minus x square and minus xy cube. So including this we have, because now this becomes minus x square p minus q and plus xz. So from 2 this is 0. Now px square minus x square minus is equal to 0. We take x common, xp minus x minus yq. So this is 0 because from 1. By using 1 this is 0. So fg is 0. Fg is 0, therefore equation 1 and 2 are compatible. Then we find the solution of this. So solution. So we solve equation 1 and 2 for P and Q. So this is equation 1 is xp minus yq minus x is equal to 0 and x square p plus q minus xz. We multiply it by x. So this becomes x square p minus xyq minus x square is equal to 0 x square p and subtract plus q minus xz. So this is minus, this is plus. So here we take q minus 1 plus xy is equal to, this is x square minus xz. So q is equal to, we take common x and sign change, so z minus x upon 1 plus xy, and p, if we multiply the second equation by y, so xp minus yq minus x is 0, x square y p plus yq minus x yz. So we add xp common, 1 plus xy, both are negative, we take on another side x plus xyz. So x cancels out, so p is equal to 1 plus yz upon 1 plus xy. Now we put in dz equal to p dx plus q dy. So we have values of p and q. We put in this. We cross multiply. Now we rearrange the terms on right hand side. We take z common, So y dx, and from here x dy from this term, plus dx and minus x square dy. So now we take z terms on one side and rest of the terms another. 1 plus xy dz minus zy dx plus x dy is equal to dx minus x square. So this is the differentiation of xy. So 1 plus xy dz minus zd of xy, and we take from here is equal to dx minus x square dy. So we do some manipulation, we divide it by 1 plus xy whole square. 1 plus xy whole square is equal to 1 plus xy whole square. So this type of step we cannot do without practice, that we have to divide by x plus y whole square. So this comes right hand side, d of x upon x square minus dy. We are dividing by x square in denominator as well as in numerator. So 1 upon x plus y whole square, so this is square, is equal to this, and this is equal to left hand side d of z upon x 1 plus xy whole square. 1 plus xy and 1 plus xy means denominator square, then denominator and differentiation of z is dz minus z into differentiation of 1 plus xy whole square, which comes so differentiation of 1 plus xy is equal to differentiation of xy. Now we integrate, so this becomes z upon 1 plus xy is equal to, here if we see that this is differentiation of, if we take minus common, y plus 1 upon x. So if we differentiate it, it becomes dy with minus, and 1 upon x gives minus 1 upon x square dx. So this can be written as minus y plus 1 upon x, y plus 1 upon x whole square. So this is minus 1 upon y plus 1 upon x. So now we take LCM here, xy plus 1 and minus x. So denominator cancels out, and z plus x is equal to c. If constant we take, then in cross multiplication 1 plus xy also comes. This is plus, this whole thing is